Finally, we have part D in example 3. This is given a temperature at 100 degrees C, a quality, or X, is equal to 60%, or 0.6, and we're asked to find what is the specific volume in meters cubed per kilogram. Now, if you look in your table B7 on page 650 in Felder, you can see that there is actually not a saturation temperature of 100 degrees C, because as opposed to being in atmospheres, this table is in bar. So I'm going to cheat slightly and say 99.6 degrees C is basically 100 degrees C. But you could do this exercise interpolating between 151.8 degrees C and 99.6 degrees C to find 100 degrees C for all these values. That's just not a valuable use of your time. So for our purposes, 100 degrees C is going to be basically 99.6 degrees C. And it's only 0.4 degrees different, so not a big deal. So we're asked to find the specific volume. So immediately we know that it must lie in this envelope, in this liquid vapor envelope. We just don't know where yet. So we can set it up on the phase diagram as having 100 degrees on our line of constant temperature. If you look at the left-hand side columns of table B7 on 650, we can see that for 1 bar and 99.6 degrees C, our specific volume for saturated water is, go down to 99.6 degrees C. The specific volume here is 0.00104 meters cubed per kilogram. And for saturated steam, it's 1.69 meters cubed per kilogram. So that corresponds to these 2 points on our envelope, 0.00104 and 1.69. So somewhere 60% of the way, and this is 0, and this is 1.0, 0.6 is going to lie somewhere along here. And we want to find that specific volume. That's the question. So to do so, we need to use a formula that involves quality. So if we set it up for a specific volume, this is our specific volume of interest, we have the specific volume of water plus quality times the specific volume of steam minus the specific volume of water. So in our case, this amounts to 0.00104 meters cubed per kilogram plus 0.6, which is the quality we're asked to use, times 1.69 minus 0.00104 meters cubed per kilogram. When we evaluate that, we find that at this quality, the specific volume, or the inverse of the density for the steam, is 1.014 meters cubed per kilogram. So this point here, and it lies between 1.69 and 0.00104. So we've identified it on the TV diagram. We've identified it, and we've identified what the specific volume is at this point as well. So that's how you use quality to find the specific volume between a saturated vapor and a saturated liquid. And you could do this at any pressure that you can find on your table, from the lowest pressure, which on this table is 0.1 bar, all the way up to the critical pressure, which is 221.2 bar.